So here we have some examples. So we're using this figure here on the right. And so number one says, what are two other names for xy? So here we have the line xy, right? So it's the line with the points x and y on it. And so we could also call it ry, right? Those are two other. So remember, we just need any 2 points on that line. So since our x and y are collinear, we can use any combination of those 3 points to make to name our line, right? So we can say ry. We can also say xr, and then we can flip those names around, right? We can say rx, yr, or we can say yx. Okay. All right. Number two, what are the opposite rays? So we, based on just the picture alone, if we just use the points that are given, we really only have two opposite rays. So see if you can figure those out. Yeah, and if you said ry, go in that direction, and then rx, go in the other direction, that would be the correct answer in terms of if we're just using the points that are given, right? So rx and ry, right? Now, you could, if you use some creative liberty, you could add another point somewhere on this rs line. You know, you could call this T or something, and then you could have RT and RS, and those would be opposite rays as well. Or you could even add a point over here, right? You could add M, and you could say SM and SR would be opposite rays as well, okay? But based on what we're given, those are easy. Number three, what is the intersection of two planes? So let me clear out some stuff here. Don't want to clear that out. So the intersection of two planes, so we have this plane here, right? And then we have this plane here. And so the intersection of those two planes where they cross, we can see that they cross here and here, right? So that, remember, two planes, when they intersect, they make exactly one line, right? So that line in the purple there, or let me make it in red just to make it a little more clear. That's the line that they make. And so that line is RS, right? Or SR. Okay, so remember, when they say intersection of two planes, that means it's going to be one line, right? Based on postulate 1.3, right? If two planes intersect, they intersect in exactly one line. All right. Number four, a segment has endpoints at R and S. What are the two names for the segment? So it's pretty easy, right? We don't even need the picture. It's going to be RS, right? And it's going to be SR. All right. Number five, are ray AB and ray BA the same ray? And the answer is no, right? Because first of all, they have different endpoints, right? And so if they have different endpoints, they can't be the same. So ray, yeah, and we don't have a picture for that one. It's not in the picture, but if we have points A and B, right, ray AB would go this way, right? If this were A and this were B, and ray BA would go this way, right? All right. So number six, why do you use two arrowheads when showing or naming a line such as EF? Because they go forever in both directions, right? So that's why on that one. And then number seven, how is naming a ray similar to naming a line? How is it different? Yeah, so with the line, remember, it's interchangeable. With a line, AB is the same as BA. With the ray, AB is not the same as BA, like we saw in number five, right? So, and also the symbol is different, right? We have this symbol for a line, and for ray, we have this symbol, right? Because it has an endpoint, has one endpoint. So on one side, it's going to stop, and the other side it's going to go forever. All right. All right, so here we're sketching and labeling these figures. We're going to use dashes for parts that are hidden from the view. So 21, we have line AB that intersects plane X at point C. So let me draw the plane first. So we have plane X here. Okay, remember a lot of times we use 3 letters to make a plane, so but we'll just indulge them here. So then we have a line AB, so that line is going to come from one side, and then it's going to intersect at point C, so this is point C here. And then it's going to keep going through the plane right to the other side. And actually this should be solid here, right? Okay, and so now that's line AB, but I need to show that it is line AB by putting points AB on there. So so somewhere we'll throw in A and B. That could be really anywhere on the line. So put A here, and just put B here. Okay, but you could put B over here. You could put A and B both over there. You could put both A and B, on either side of C, however you want to do it. All right, 22, 2 planes, M and N that intersect at line L. So draw one plane. This is for number 22. So we have one plane here, and then we can draw another plane. And usually for me, I'll draw where they intersect, or the ends of the intersect on the. So this comes through like this, and goes through on this side. Need my artistic ability here. So that would be the line that they intersect, right? So they intersect at line L. So that would be L. This would be plane N. And this would be plane M. All right. Okay, and then 23, horizontal plane that connects 2 lines, R, S, and TU that intersect at point O. All right, so we'll first draw a horizontal plane P. Try to make it look horizontal there. So there's plane P, and then we have 2 lines that contains the 2 lines, so these lines are coplanar. So we have one line that's on that horizontal plane, and we have another line that's on that horizontal plane. Okay, and I forgot to label the points here. So we have one line that's RS, and the other line that is TU. Right, and then they intersect at point O. All right. So just, being able to visualize these and understand what all these terms are, that's kind of the idea of these examples here. All right, so next one's 19 and 21. We're trying to name 2 planes that intersect at the given line, right? So number 19, given this figure here, we're trying to figure out the 2 planes that intersect at QU, right? So here's the QU, right? And remember the line goes forever in both directions. But the 2 planes that intersect at that line are this plane. So we can say plane UVR or QUV, however you want to say it. So plane UVR. And then the other plane is this plane here, right? So that would be plane QUX. Okay. All right, and notice that both planes have Q and U on them, right? All right, and then 21 xt. So xt is this one here. So one plane is the one we just mentioned, right? Which is QUX, right? That one's one of them. And the other one is going to be this one here. So plane XWT. All right. Okay, so the next one says copy the figure, shade the plane that contains the given points. So RVW. So this is R down here. Can't see it on my. So RVW. So that would be this plane here, right? All right, and then UXS. So remember, through any three non-collinear points, there's exactly one plane, right? So UXS, so that would be this plane here. All right. So this on 33 and 36, if possible, draw a figure to fit each description, otherwise write not possible. So 4 points that are collinear. So 4 points, let's make them A. And actually, you know, maybe an easier way to do this is just draw a line and then draw the points on the line, right? A, B, C. How many points could be collinear? That's right, infinite amount, right? I heard you out there, Simon, thinking about that. So, because when you're thinking, I heard the sound of you thinking. But anyway, A, B, C, D are all on the same line, right? And there's an infinite amount of points all on that same line, so that we could draw however many points we wanted on that line. So here, 3 points that are non-coplanar. That is not possible, right? Because going back to our postulates, postulate 1.4 says through any three non-collinear points, there's exactly one plane, right? So if you had three collinear points, not only would they be collinear, of course, but they could be, you know, if they're on the same line, of course they're going to be on the same plane. They could be on actually an infinite number of planes. So yeah, so through any 3 points, there's always one plane, okay? At least in our physical realm, okay? All right, and then 53 and 55, the last examples here, it says graph the points and state whether they are collinear. All right, so 1, 1, it's right there. 4, 4, and -3, 3. All right, so yeah, those are all collinear, right? If I have a straight edge, I can line those up, and they would all align along that straight edge, and I could draw a line that connects all those points, right? So a straight line. So these are collinear. All right, 55, 0, 0, -5, 1, and 6, -2. All right, so these ones kind of look like they could be collinear, right? But if we lined a straight edge, they're not, right? There's one line that goes through these 2 points, right? And it's not the same as the line that goes through these 2 points. That was a bad. Okay, so those are not the same line, not collinear. There's one line that goes, you remember there's through any 2 points, there's exactly one line. So through this point and this point, there's a different line than between this point and this point, right? So, whereas with these, if you draw a line between any of these pairs of points, you'll get the same line. All right, let me know if you have any questions, bring them to class, email me, text me on the Google Voice, and see you in class.